Welcome to Worcester Union Station, situated in downtown Worcester, Massachusetts. Worcester has long been an important station, earning its Union status by serving 7 railroads in the 19th century. Looks like there's a route map missing. Place it while you're here. There are more route tasks to discover, so make sure to apply missing route maps, put up posters, find the red socks, and put up the warning signs. The preceding Union Station was designed by the firm Ware and Van Brunt and served the city for 35 years before it was demolished. In the late 20th century, the frequency of trains diminished, leading to the station's closure in 1972, which later fell into disrepair. Although the building was disused, in 1980 it was added to the National Register of Historic Places. In 1992, 20 years after closing its doors, a non-profit group began fundraising to restore the station. In the year 2000, after completing a $32 million restoration project, the station reopened. The station retained its Union Station status with MBTA and Amtrak now operating services. MBTA reported that in 2018, the station averages 1,300 passengers who board at Worcester each week. Take charge of passenger traffic in dashing MBTA Purple and run through the commuter suburbs of central Massachusetts. Operate the sleek HSP 46, twinned with modern bi-level equipment on the bustling rails out of Boston's South and Back Bay, out onto the busy Framingham-Worcester line. This is Train Sim World, MBTA Commuter, Boston Framingham Worcester line. In this training module, you will be learning to drive the MPI HSP-46 diesel-electric locomotive. You will need to set the generator field switch. This needs to be enabled for the locomotive to generate power. Insert the reverser. Release the brakes. Now you're all set up, you can open the doors. Nice work. Close the doors and get ready to depart. Set the reverser to forward. This controls the direction of travel. Use the master controller to apply some power and get moving. you've built up some speed, you can start coasting. On level grades, you can coast to maintain your speed, reducing energy consumption and stress on the motors. When coasting, always remain vigilant of the grade, as changes could cause the train to speed up or slow down. Keeping to speed limits is important. If you begin overspeeding, apply a small amount of braking force. The MPI HSP-46 is an AC traction diesel-electric locomotive for commuter trains, designed and built by Motive Power. In the mid-2000s, MBTA issued a request for proposals to replace its aging fleet. MBTA chose the HSP-46 locomotives, powered by GE Gevo 12 diesel engines from GE Transportation. These engines meet the new Tier 3 emission standards enforced by the EPA. You are approaching the station. Begin applying a small amount of braking force. Nice work. The train has safely come to a stop. You can now open the doors. Good job. That concludes all of the basics of operating this locomotive. In this training module, you will be learning to drive the CTC-5 control trailer coach. Set the reverser to forward. This controls the direction of travel. You're ready to open the doors. Use the throttle to apply some power and get moving. you've built up some speed, you can start coasting. On level grades, you can coast to maintain your speed, reducing energy consumption and stress on the motors. When coasting, always remain vigilant of the grade, as changes could cause the train to speed up or slow down. Keeping to speed limits is important. If you begin overspeeding, apply a small amount of braking force. Approaching the station, begin applying a small amount of braking force. Nice work. The train has safely come to a stop. You can now open the doors. Good job. That concludes all of the basics of operating this control trailer coach. In this training module, you will be taken through the basics of understanding ATC, Automatic Train Control, and ACSES, Advanced Civil Speed Enforcement System. ATC and ACSES work together to relay signal aspects and speed restrictions to the equipment in the cab. You should always follow in cab signaling, even if you have not enabled enforcement. Now that ATC and ACSES enforcement has been enabled, penalties may be applied if speed limits are violated or if system alarms are not properly acknowledged. Now, let's take a look at the in-cab equipment. All relevant information pertaining to ATC and ACSES will be displayed on the SDU Speed Display Unit. Most of your information will be displayed in this SDU. The speed limit indicator on the SDU displays the current ATC or ACSES aspect, depending on which is illuminated. The area is currently under ACSES. Below that is a speedometer. You should always adhere to the lowest of these two speeds, even if enforcement isn't enabled. Let's get moving and see how ATC and ACSES will enforce speed limit changes. The SDU is currently showing the track speed limit, which must not be exceeded. The alerter will sound periodically if certain controls are not interacted with. When this happens, you must acknowledge the alerter or penalty braking will be applied. If a penalty brake application occurs, recover control of the train by setting the brake handle to suppression or greater and acknowledging the alarm. Once at or below the required speed, the brakes can be released. This is called a running release. The SDU is currently displaying a clear aspect, meaning that you are able to proceed, not exceeding the maximum authorized speed. The onboard computer keeps track of the train's position and calculates a safe braking curve for upcoming ACSES speed restrictions. The next signal is displaying a less favorable aspect than clear. When passing this point, the cab signal aspect on the SDU will change in order to conform. The ACSES onboard computer keeps track of the train's current position and calculates a safe braking curve for upcoming speed restrictions. If the braking curve is ever violated, ACSES initiates a penalty brake application. Overspeeding may result in a penalty brake application. Always adhere to the maximum authorized speed. ACSES allows for operating up to 3 miles per hour over the maximum authorized speed. Any higher and an alarm will sound. If this occurs, you have 8 seconds to reduce your speed before a penalty brake application. If the maximum authorized speed is exceeded by 6 miles per hour or more, an immediate penalty brake application will occur. Remember, always adhere to the maximum authorized speed shown on the SDU, even if ACSES enforcement is disabled. Failure to do so may create unsafe conditions on the line. As an engineer in training, you should operate a few miles per hour below the maximum authorized speed. This will give you enough of a buffer to reliably avoid speeding penalties and react to speed reductions. That covers the basics of the ATC and ACSES safety systems. You can always replay this training module if you need a refresher on these topics.